All right, now as you take a look at doing these, think of order of operations. You still use your normal order of operations. So like if I'm looking at number 1, I have 2 sets of parentheses, but there's nothing I can do that is just inside of either set of parentheses. So there's no simplifying to be done just inside. So after parentheses is the exponent. So the first thing I want to do is actually deal with this exponent that's being applied to that parenthesis. So the first one stays exactly the same. So 3, a cubed, b cubed. Now I square this. Now when I'm squaring this, notice that the 4 here, the 4 is just a number. It's not an exponent. So I don't use some special rule for it. I literally just take the 4 and square it. And so 4 squared gives me 16. Then I do a squared, and then I do b to the 4th power. Because a power to a power means multiply those exponents. Now this is not the answer, it's just part way through. So from here, go ahead and do the multiplication. And then to do that multiplication, the 3 and the 16 are the numbers. They're not exponents or anything, so I can just multiply those like I'd multiply any other numbers. So 3 times 16 gives me 48. Now I do with the a's, I got a cubed times a squared. When I multiply the variables, I add the exponents. So that becomes a to the 5th. And then I go on to the b's, and again I add their exponents, so 3 plus 4 gives me 7. So there's my final answer for number 1. When doing number 2, again we go order of operations. So the first thing I'm going to do is deal with this exponent that's being applied. So I'm putting this 3 into the parentheses. So this 3 that we have sitting inside the parentheses, notice that 3, again though, is just a number. It's not an exponent. So it's not like I have to remember some special rule with it. I'm literally just going to do 3 cubed. And 3 cubed is 27. And then I go on to the x. Now the 2 is an exponent, so I do have to remember the special exponent rule there. When we have a power to a power, we multiply those 2 exponents. And so that is going to give me x to the power of 6. Now the bottom, there's nothing we've been able to do yet, so that is just 2x to the 7th. The last step is to simplify that resulting fraction. And can we reduce 27 over 2 at all? No, so it stays 27 over 2. Can we reduce the x's at all? Yeah. I got 6 on top, 7 on bottom. When I divide, I'm supposed to subtract. Well, 6 minus 7 is a negative 1. The fact that that's a negative tells me that that x goes in the bottom of the fraction. So x to the negative 1 becomes an over x. When doing number 3, I do want to mention one thing in particular. There's a couple different schools of thought about how you approach a problem like number 3. One of them is, hey, I got a whole bunch of b's. I'm going to start by doing all the addition and subtraction of those right at the start. So that would mean I'd do 4 plus the negative 5, and I'd take that and I'd subtract negative 3 from that. You can do that. That is perfectly fine. The other way of doing it is where you start by just getting rid of the negatives and then do all of that. If you did it that way, that would be the 2's left alone. The b to the 4th, it's left alone because it's a positive exponent. But that b to the negative 5, it becomes a b to the 5th on the bottom because the negative exponent flips it in the fraction. Just like the b to the negative 3rd on the bottom flips that b to the 3rd to the top. And then we could do the addition and subtraction from there. So like I could do the 4 plus the 3, which gives me 7, minus the 5 on the bottom, that gives me 2. So I end up with 2 times b squared for my final answer. Whichever way you do it is fine. Just go with the one that's going to be the most consistent and feel the best for you. All right, with number 4 here, we know from our notes that you took down that I could rewrite this as x to the power of 7/3. And that is correct, but it is not a final answer. Because when we're simplifying these exponents, we don't want to ever leave a fraction in our exponent. We never want to leave it that way. And now you might be then tempted to just rewrite it back the way the original problem was. But actually we don't want to do that because it can be reduced. It can be simplified. And in order to simplify it, one of the great ways to be able to see it, at least I think so, is by taking our 7/3 here and writing it as a mixed number. What is 7/3 as a mixed number? It is 2 1/3, yes. And so this becomes x to the power of, oops, got to go back to the other color here, 2 1/3. So I now have x to the power of 2 1/3. That is the same as x to the power of 2 times x to the power of 1/3, which is x squared times the cube root of x. That's our final answer on that one. And then you go on to number 5, and yes, you can do number 5 without a calculator. All right, now when doing number 5, if it's giving you trouble, we have to know that in order to use our exponent rules that we need to make the bases the same. And these we actually can make the same. The trick to being able to do this one is knowing that 27 equals 3 to the power of what? 3. 27 is 3 cubed. So if I know that, that then lets me write this whole fraction as the 3 to the 7th on top, staying the same, over 3 cubed. And then remember, this 27 is being cubed here, so then that must be cubed. So this whole thing just is 3 to the 7th over 3 to the 9th. Now we can actually simplify it. And notice, no calculator needed here. So I use my normal exponent rules. I do the 7 minus the 9, which gives me -2. So that means this equals 1 over 3 squared. Because remember, if it's a negative exponent, that means flip it into the bottom. And 1 over 3 squared equals 1/9. That is our final answer. A little side note on that, though, before we move on to the next set of questions. Every now and then I have somebody who says, hey, at the start, can I just reduce this 3 over 27 into 1/9? No. They have different exponents on them. That would not work. And yet you might be then sitting there saying, yeah, but it gave us 1/9. That's just happenstance. If either of these exponents had been different at the start, we would not have gotten 1/9 at the end. So don't think that that's a rule that we can generalize to other problems. It just happened to work that way. Now if you got those, then you should be able to handle these okay. 3 of these 4 are actually pretty straightforward and pretty doable. Yeah, I know that leaves one other one. All right, let's take a look at these and actually see what each of these is going to work out to be now. First one, number 1 here. Again, we want to start with the exponent part first. Order of operations, there's nothing I can do inside the parentheses, but I can do the exponent to it. So the x, it's just going to be hanging out front here as I move forward. So next up, I'm going to be doing the 3 to the power of 3 here. Again, remember, notice this 3 here, it's just a whole number. It's just a regular number, not an exponent, so I do 3 cubed like any other number would. So that's going to give us 27. And then we got the x squared cubed. And the 2, it is an exponent. So that means I use the exponent rules here. Power to a power means multiply them, so that's going to give me x to the power of 6. Now I see what can I simplify from here. Notice I can combine those two x's. If I do x times x to the 6, that will give me x to the power of 7. Because of course that x, remember, is x to the power of 1. We just don't write in the 1. All right, now for number 2. Again, you could start by just going ahead and doing the subtraction, and getting your answer that way. Or again, if you start by flipping everything that has a negative exponent on it, you could do that as well. Write up what that would look like so you can see if that's the way that you approached it. Either way, go ahead and add those exponents now on the top. So y to the 4, y cubed, that's going to give us y to the 7th. And then the x's on the bottom, the 2 plus the 3 gives me x to the power of 5. And again, you could have gotten that from the start because you would have done -2 minus 3 is a -5, and the negative would tell you put it in the bottom. And then you would have done 4 minus -3, which would give you positive 7, which tells you put that 7 in the top. All right, number 3, I'm actually going to save for last because it was the toughest problem on this page. So let's take a quick look at number 4, then we'll come back to it. So for number 4, I'm squaring the fraction. That means I square everything in the top and the bottom of this fraction. So on the top then, I'm going to do 2 squared. which is 4. I'm going to do y squared, which is y squared. On the bottom, I'm going to do x cubed squared, which means a power to a power, so multiply those, that gives me x to the power of 6. And notice there's nothing in that fraction now that's like anything else in that fraction, so there is definitely nothing else we can do. That is our final answer. Now, if you are still writing any of those down, get that problem written down and the work with it, because it's about to need to make way, because I want to have lots of room to be able to show number 3 as clearly as I can, because that's the one that trips people up. As you're doing that, let's take a look at what answer we're going to be headed toward on number 3. On number 3, the final answer is going to end up being 7 times the cube root of x, not x squared, x, over, I'm sorry, not x, I know, I just caught it, y, cube root of y, over y squared. That is what it's going to be like. And a lot of people end up saying, wait, shouldn't it be the cube root of y squared on top? No. And we're going to be saying y here in a moment. So let's actually make ourselves some room and take a look at how that work might look. And again, there's a couple different ways you could approach it. So if you got that answer without doing the work this way, you did a slightly different way, that's probably okay. But let's see. The most common way of approaching this problem is we start by simplifying that radical on the bottom. So it becomes y to the 5/3. And just like we did on the previous set of examples, we had that one where we simplified that radical. That becomes 7 over y to the 1 and 5/3. I'm sorry, 1 and 2/3. Which then becomes 7 over y times y to the 2/3. And this is why we needed so much more room. I'll just pick up next to it. Okay. And so that would give us 7 over y to the cube root of y squared. Personally, I think this is the longer route, but it's okay. Now, what can you multiply the cube root of y squared by to make it into a whole y? Well, this is one way where actually putting in the radical might actually make your life a little bit harder. Let's go back and take a look at that previous step, because this is what I see most, but I want to actually show you how you can make your life a little easier by working from this fraction instead. From that fraction, 2/3 plus what is 1? 1/3. And so I would actually need to put y to the 1/3 into both the top and the bottom. This is the part that tends to mess with our heads a little bit. And if you do that, that's where we get our cube root of y on the top. And on the bottom, actually I'll go ahead and put that in here, 7 y to the 1/3. And then it's y times, then the 2/3 plus the 1/3 gives me 1, so that's y. So that's how we get the cube root of y on top and the y squared on bottom. Now again, I said there's multiple ways to do it. This is just one of the ways. Now, personally, this isn't the way that I approach it. So I want to show you the way that I think about it, because it saves a few steps and it builds on this knowledge that you've seen before. And I think in some ways makes it a bit simpler too, once you get the hang of it. Alright, so I'm going to take a look at putting in a different method over here. So again, I'm going to start with this same idea that I did here, where I'm going to make it into 7 over y to the 5/3. But rather than turning the 5/3 into 1 and 2/3 and all that stuff right now, 5/3 plus what equals a whole number? 1/3. And all I need is a whole number. It doesn't have to be a particular whole number, it just needs to be a whole number. So since I need to add 1/3 to that, that tells me to multiply the top and bottom by the y to the 1/3. And if I do that, then I get that 7y to the 1/3 over y to the 6/3. And of course, you can then see the 6/3 becomes a 2. That's why we get the y squared on the bottom. And the y to the 1/3 on top, it becomes the cube root of y. Out of all of these problems, that is absolutely the hardest of them. Dealing with the radicals can easily throw people off, especially because you've done tons of practice when you have a square root in the bottom of a fraction, but you haven't done nearly as much practice when it's a different kind of root, such as a cube root like in this case.